Hi guys, in this stream I'll be looking through the FXGL code and try to integrate the scripting engine into the entity component system that we have. So the idea is to push the integration of the scripting engine further into the FXGL architecture, and so that we can do a lot of interesting things. I don't know what I'm going to achieve by the end of the stream. Hopefully something that works. So basically what I have now is a sample that is being compiled right now. And so the two red things that you're seeing are supposed to be something like buttons or something that is in the game that you can kind of go near, activate somehow by presuming by pressing a button or something, and it will do something. So the button does it's being activated by the player, say, which could be any other entity really, and it just makes things a lot more interesting because you can then have interactive objects right in the game world. So think about think Skyrim, I think. Yeah, that's a good example. Where you can have lots of things like levers, various buttons that chains, I think, you can kind of activate, and they open doors or trigger something. And the code that runs once something is triggered is written in a scripted language for Skyrim's creation kit, I think. And this is what really inspired me to do a scripting engine and integrate it with FXGL. Now, strictly speaking, we don't have our own scripting engine. It comes from the JDK JavaScript engine. So basically what we're writing is JavaScript code, which is good because we don't need to create our own language. So if I'm close to that thing, I can press F because I just assigned F to be the activating button. And some stuff happens. So this prints unactivate1, which is basically a script for the first button. And there's a script for the second button, which is currently throwing an exception. Right. So far, I've only got to a stage where I can pass a Java object to a script. So this is basically a script. And what I want to be able to do now, do something like this, where I can pass a JavaScript object into JavaScript code. I've already done some basic plumbing, so to speak, and that's what we're doing. So ignore that, that will just basically create an event, and that event is going to be then converted into a JavaScript object with this code. So we're creating a JavaScript function, and then we're defining, we're declaring an object and assigning its properties on the fly. And the values of those properties come from Java, which is pretty cool because we don't need to use things like that. So we don't need to be very verbose, so to speak. And we can just call this .name as opposed to .getData name. Scripting language is supposed to be less verbose and kind of supposed to speed up the development. So that's what we're doing. I don't know how the API is going to work yet. This is all very early stage for the scripting integration. And yeah, we'll see how it goes. Also, what I want to do is unify both Java handling of events and JavaScript handling of events, so that you don't need to kind of write separate code. That would be nice. So we could fire the event in terms of FXGL event bus, and also fire a JavaScript event, but then they will be handled in the same way. So basically this event is going to be the same event in JavaScript, but with those accessible properties. As you can see, this is hard-coded, so I will need to make this generatable at runtime, so dynamically. What else do we have? As you can see, lots of to-dos. So this is basically a foundation of what's going to be a scripting engine for FXGL. First of all, let's make those things bigger. So you can actually see them on the screen. So these are two red buttons. That's what I'm going to call them. And now what I want to do is get rid of some playground code that I no longer need. So yeah, this is how you handle events in Java or in FXGL at the moment. And that's what is going to be similarly done in JavaScript, I think. Because I quite like passing the event. Because you can add a lot of interesting things to an event without worrying about the number of parameters that you can pass to a function. So our event is going to just store this data, and we don't need to worry about the number of things we pass in. We'll just, I don't need to close some stuff. Don't need that. Don't need that. And the other interesting thing about this is being able to kind of create scripts from level data, because not every game is going to be created using this, because that's pretty much hard coding. And what we want to be able to do is to use an external tool like tiled map editor and use its object properties to set certain things like this. Currently, the integration with tiled allows us to write these in the tiled editor and then export this as JSON, which is then parsed into a FXGL level. And these are automatically parsed into entity properties, which we can access. And this is how I'm accessing, for example, things that are supposed to be relevant for the onActivate script. Things like name and ID. So this is probably how we're going to do the parameter passing. In which case we can say onActivate is going to call a particular script, say this. So event, this is the JavaScript object that will be created or wrapped. And then we're going to be able to use it as a native JavaScript object and query its data that we're interested in. And that data is going to be passed through this, using this approach, basically. I don't know if it makes a lot of sense right now, but it does in my head, and hopefully this will work. But it's the kind of very first approach anyway, so we'll see if it does or doesn't work. Right. let's start with making this dynamic. We'll need this part, and then we'll need some code in between, and then we'll need that. It's going to call the function, which will return the object, and that object is going to be returned back here. So this Java object is going to point to a JavaScript object, which is then going to be passed to a JavaScript function. And on activate, if defined, like here, will be passed down here, so we can actually utilize the object. So if I remove this, then we can start from here. And these things essentially come from that. So the event object needs to expose its data. Okay. We'll do it this way for now, and then we can refactor it if we need to. And then these are going to be parsed dynamically, and then we return the object. So this part needs to go here. So it's events, event data, for each key value. Now it's entry. Can we not destructure it? Oh, right, this is object map as opposed to hash map. Fair enough. I'll just use the keyword. Right, so event data for each script, add object dot the name and that's the key. Then assignment and its value and semicolon to end the statement. Now the problem here is with if the value is string, it needs to be wrapped with quotation marks, right? In which case we need to check the value type. And this is getting quite heavy here. let's define another function. Wrap value. And it gives back a string. In which case we can do wrap value like this, and depending if it's a string or not, because I'm pretty sure that is only needed for a string. I don't think of any other cases where in JavaScript you would use quotation marks, because everything else is a reference or a value type. Yeah, let's go with that. So if value is of type string, then we're going to return that, and then the value itself, and then another quotation mark as a string. Yeah, that's fine. Else we return, what do we return? The value itself. Is that true? I think so. Yeah, and let's do it for the lead. Yeah. Yeah, if value is string, then put the quotation marks around it, else return the value as it is. And that is going to spawn a property of a JavaScript object dynamically. It's pretty good. Yeah, and we no longer need this. We can evaluate the script, which is going to be here. Or we can just do that. Call function unactivate. Yeah. Ideally, all of this is going to be lifted as well, because you can see here I've got another component, a live component, which fires two types of events, two events, kill or death and revive. And so the code is very similar, which means we can do some refactoring there. So this will probably be generic some point. I was hoping to kind of do something like this, where we can define the types of events that are going to be generated by this component, and then on, say, activate, it'll just go through the list and call things when needed. But we'll see. Call function this with the results. Basically, we can do that. So I'm very happy with the type of the object that this thing returns. We don't need to return anything. It's void, isn't it? Might actually fail if we return nothing. I don't know. Okay, let's try that. So this is the guard. This is where the script is generated. and that is going to call the script. And that should work with our first script, because the second script is still the old script, which I need to rewrite. Okay, so it does work. Cool. And it moves down because it basically identifies, well, it prints this thing first. Then it finds the entity with the name and ID. And as you can see, I'm accessing these things directly without the need for method calls. So this is actually a native JavaScript object, which has been generated by this thing. And its name and ID properties, they're basically fields in JavaScript that are called properties, were generated dynamically, which is awesome, really, because it allows us to first pass a scoped object to some JavaScript code, meaning we don't have access to it from Java code, because otherwise it would have been access modifier violation, I think, because we don't want to expose internal data. That's the point. However, from JavaScript point of view, there is nothing similar to private, so we can access the stuff regardless. And it allows us to kind of avoid all the complexity of writing function name as opposed to just getting the property directly. And if that entity is present, which it is, it goes to access this by ID. So name and ID, which are name Wanderer ID 0. And this particular entity has this ID component. So IDs are the pair of ID and value, ID and name are those pairs are unique, which means we can access some entities in the game world without having need to search for them. We can just reference them kind of directly. But we need to make sure that the entity is actually present, because if it isn't, then we might end up with accessing null stuff, which we don't want. And this is why this is wrapped with optional. So if present, then we supply a consumer object, which is basically a consumer function. Takes an entity, returns nothing. And what it does is sets y to get y plus 20, which is, well, what's that thing doing? It moves it down by 20 pixels. So that thing basically worked. That's the takeaway message. So we don't need that anymore, don't think. This will probably go into its own function, or that thing will. Something like call JavaScript event or something. So I'm going to separate it a little bit. So that void is basically happy with this being called as void. Right. So we've done that part. This needs to be generated dynamically as well, because we don't know how many parameters we're going to pass and what kind of parameters there are. The only thing we know is, or that's basically what we define really, because we're defining our scripting engine. Currently, we're going to say that the name of the event is going to be prefixed to the parameter name. So anything on activate dot is going to reference an object that will be used in here. Currently we're using name and ID, and therefore these two things are present. Because if they're not, then someone made a mistake. Either the game level designer or the game scripter. Let's fix the second event now. Let's make it do something different. What shall we do to it? Let's notify the user. So we can, if you've been following FXGL development, then you know that we can access a lot of things now from JavaScript. So we can do notify, and all the things that we can access are actually in this single file, which is pretty cool, because you can add to it, and I will do, to create a one-to-one mapping between JavaScript and our domain-specific language, which is this, which is written in Kotlin and allows us to make our code more concise once you get to know your the FXGL code. So get I returns an integer, get D returns a double kind of global variable, global game state variable. And we can do asset loading, play audio, record, register various inputs, events. What we do want to do is notify. So notify takes a message, and that pushes a notification. This is still using the system notification because we don't have an in-game notification yet, but we'll do at some point. So that notify, for example, maps to, it's not currently mapped directly, it just repeats what this thing does. But ideally, it will be mapped like this. And so let's do notify. And let's get event dot something that we're interested in. And this will show real power of dynamic properties. So this is our second enemy, or button. It's going to have a, well, it does have a different script. And what I'm going to do is add a different, so we don't need that. On activate message, that'd be cool. Message is going to be something like you activated this entity. Yeah, that's good enough. So that message is the name of the property, which means we can do event of message, which we still can't do because of this. This is hard-coded, as you can see. So I'm going to fix that now so that the message thing can work, because I'm hoping this is now generic enough to work for everything. Should be great. So event set data. Now I need to go through. Can I access entity properties in general? No. Okay, so that needs to be accessible now. Let's tentatively add this and then we'll fix that. Maybe. So this is going to be accessible now. Get properties. I can now search through the keys. Alternatively, I can just return property keys and hide or encapsulate this, keep this encapsulated. So entity properties. All I need is keys. Yep. For each key, I need to search Actually, I need to filter them. I need to filter them so that the key starts with the function name, particular script name. So for this, which is activator component, it's going to be on activate. And considering this will be done on each component basis, I can see this being refactored into some generic kind of scriptable component class that will then perform all the things. Because as you can see, if we start adding more things into this component, which is a live component, on death, I will still need to rerun the same snippet, essentially. So it really could be isolated. So we no longer need this. We'll filter that. Once we've filtered for each, we'll just do event set data it remove prefix, I think. Yeah, which is on activate. Again, there's quite a lot of repetition here going on. So I'm hoping that we can get rid of that. Move prefix, so that's the key. Move prefix activate dot, because there's a dot in there. So we need to remove that part and only keep that part. This will return new string, which means I can still use the it object. And the value is going to be accessed from the entity. Get property key. I don't need to check for optional because I definitely know there's going to be a property like this because I've gone through the keys. It's just key, isn't it? Yeah, I think that's right. Let's see if it works. So now it should be generic. It should now work for both entities, even though they have different scripts. So this works. And now this should notify me. Cool. And that's the message that I passed. So as you can see, it uses the system notification, which is kind of similar to Xbox One style achievement thingy. Alright, so what else can we do? Let's see if we can make the scripts a little bit more complex. So instead of just moving it directly, we're going to show a confirmation dialog and ask the user if he wants to move the entity. That would be nice. Do we have access to show confirm? Yep, that's what we need. In JavaScript, no, not yet. So this is how you would create a convenience function in JavaScript so that you can access the FXGL domain-specific language. Show confirm. I like having the same function name so that you don't need to memorize different things. Show confirm, it takes message, right? And a callback. Callback. Doesn't return anything. And we call DSL Kotlin show confirm message callback. Yeah, that's what we do. So as you can see, it's pretty much the same thing. It just allows us to avoid having to type this, because in scripts you want to be as concise as you can. So show confirm. Do you want to move the entity? Do you want to move this entity? that's the message that will be shown in the dialog. And now I'm going to pass a callback, which is the consumer of a Boolean type. When it's a Boolean type, like callback, I like having the word yes in there, because that means you can do something like if yes, which maps naturally to whatever language you use. If yes, then this. Or we can even define, it can be even more fancier. We can create another function that we are going to call from here. Move entity. Now the only drawback, or one of the drawbacks I suppose, that you have with scripts is that you don't have IDE support to the same extent as you would in normal Java code. This, you have to know that it's kind of callable. Because it's not technically a JavaScript project. It's almost like abusing JavaScript in the context of Java. So if yes, then move entity. But then yeah, if this kind of takes off in terms of the scripting engine for FXGL, I will create a wiki specifically for this, so that we could have an easy kind of list of functions that you can create, also a list of events that you can do, listen for and fire. So yeah, hopefully this works. There we go. So there is a confirmation dialog. Do you want to move this entity? No. Nothing happens. And we do it again. Yes. Right, event is not defined. Oh yeah, right, I didn't pass it in. That's fine. Move entity. Yeah, I'll just pass in the event. What we could have done was take the event data from here and then kind of make this just the entity itself. But never mind, it's not the point. The point is we can make as complex scripts as we want. That's great. So yeah, this works now. What happened to that? Oh yeah, that still does the notification thing. Alright, so yeah, that's pretty good, I would say. So we no longer need that. This is generic now. Cool, we made most of the things as generic as we can at this stage. I suppose there are some interesting objects that we can, interesting properties that we can keep for every single event, like event caller or event trigger, something like that. So we can always be able to access these things regardless of what the particular script says. And the nice thing about these events, well, we can use them from JavaScript code, and we can also use this from Java code, because this fires actually into the event bus, which can be easily handled. So that's an entity event, which can be handled by this. So event type activate, I believe. Entity event activate. Yeah, so that's the type of the event. So here, well, we don't need this anymore. Called in Java code. So that should work. So yeah, when we fired this, as you can see, do that. So this fire fires it into the kind of FXGL event bus, which is quite global. Everyone can listen to it, which is great because you can listen to it from any part of your game. And this is just an easy way to do so. You can handle this particular event. And it also carries all the stuff that we need to. So for example, event gets data. What is it? It's going to be that, yeah, so it's name. So that should return Wanderer. Yeah, so it returns Wanderer. So it's pretty much the same event, but it has different syntax, access syntax to it. So you can access the name like this, which is what we want in Java, because we want to be able to keep everything kind of hidden, and we don't really want to do this, for example. I'll find a way to encapsulate this. But in JavaScript, we want to be able to do just that, because typing get data and then passing something is too long and too verbose. Plus, eventually, we'll be able to rewrite scripts on the fly, so modify them on the fly, which means we can run the game and make modifications to the script, so we don't have to recompile the game every time. That's another advantage of having code in a script. Plus, we want to be able to move most of the stuff to scripts anyway, so that we can consider scripts like game data as opposed to game content as opposed to game code. And I suppose if you write your game using scripts, then you are also allowing to a certain extent to produce user content. So users can produce stuff. Right. Let's do one last thing for the stream, the so-called stream, and then we'll move on. So that is somewhat complex, relatively complex. Let's do something with this so it's more interesting. What do we have access to in FXGL? Scripts. I suppose we could play around with variables, kind of global variables. So for quite some time now, we've had these global variables, which are awesome because they're backed up by a JavaFX property, each variable, so you can bind to each variable and you can listen for changes in each variable. So that's great. So we're going to create a new variable, say I don't know. Why don't we create a color variable? Blue. Sure, no. Let's do green. And then we're going to find an entity, which is that one, say, and we're going to change its color. So we're going to access its view and change the color. Yeah, let's try that. That could be interesting. And reasonably complex. So we want to be able to pass something in there. Yeah, let's do something like that. So we can refer to this particular entity. We no longer need the message, but this time we need the ID 1, because that is 1, if we want to refer to this entity. If we kept 0, then we'd simply change the color of this entity, which should be fine anyway. So now, without changing anything else in anywhere, I should be able to do something like event. So my ID, event name, event ID, if present. We know it's present, but anyway, function. So this is our callback. Is the entity. So e gets view, and that's going to return view, get children, get 0. So this will return the first children, and there's only 1, which is a rectangle. And then we're going to change the color of the rectangle. I think it's set fill. So as you can see, that is where the problem arises. You actually have to remember the API. Rectangle set fill is the color, which we can obtain, I think, using get object. Can we? Is there no way to obtain object right now? Never mind. Add one. Function object. I'm not sure if that's a keyword in JavaScript. I hope not. Game state get object. I'm pretty sure it's get object. I need to remember my API now. Get game state get object. Yep, this is game object, and we pass the property in, which is that thing. Let's call it my color. So that is now accessible from here, which means it's, did I call it get object? Just object. Object my color. And hopefully this works. Get view, get children is not a function. Right, what does get view return? Might return something that is FXGL specific. Get view, get children. Oh yeah, it's get nodes now. Get nodes, then get 0. Alright. So that's that. Get view, get nodes. Yeah, that should work. And if it does, I've just got another interesting idea. So yeah, we've just set the color to green now. Awesome. Right, just one final idea. So because it's a color, it's an object, I can't change it dynamically from within console. Because if you remember, since some version we've had a console now. So I can actually query all the variables, variables. So now it actually prints the variable type. That's great. The variable and the color, which is that, which is green. RGB, yeah, it's green because it's RGBA, so that's actually A. Yeah, so I want to be able to set variable, but in order to do that, I need some numerical variable. Let's add a new one. So variables put, let's say the Y position. That would be awesome. So enemy Y. I'm going to give it, because it's supposed to be a double. Let's do 50. Now what we can do now is not only do that, but also set Y, or even bind Y. so we don't have to call this every time. It's y property bind, and what I need is a double property in p. So it's double p, and that instead of double, it should return double property. Yeah, something along these lines. Of course, I could use the DSL, which returns get DP. Yeah, there we go. Get double property. Bind enemy y. I think that's why I called it. Yep. So it's going to change the color to green and also bind the y property of the enemy to this particular variable, which I can then change at one time. So if we go here, press F. So it's changed to 50, which is good. Open the console. So enemy y is now available as a variable. How do I set variable? Set variable name enemy y to 300. So we've changed the position of our enemy y value or global variable. And that, because the y property of this particular entity is bound to this variable, by changing that variable, we can also change the y position of that entity. So we can do this, 550. So it's there now. And yeah, that's the only thing we can do right now. So yeah, I think this proves that scripting is a very powerful tool that's going to be added to FXGL and is going to add all the extra functionality they are now going to have. From not only within code, but also from within scripts. Also, this might maybe a little bit appeal to JavaScript programmers, which can be great to kind of increase the size of the community, so to speak. Anyway, we've done some things in this stream. In particular, I've tried to generify the wrapping code so we can create JavaScript objects on the fly from Java data. So they're essentially Java objects, but they're parsed into their JavaScript counterparts without the need for calling methods. So we're just creating properties from Java fields. And then passing them to our JavaScript code, where we can do some pretty complex stuff, like accessing the dialog system or the notification/achievement system, as well as writing some pretty complex code, like binding stuff to one thing to another, etc. So yeah, before the commit, I'll clean this up, and then hopefully this will make its way into the next version, which is 0.4.1. So that's the snapshot that I've been using. Yeah, I think that's going to be it for the stream. Let me know if there are any features that I've missed. The issue list is getting bigger and bigger every time I write something in there. The wiki, yeah, I haven't had time to update the wiki yet, so it would be great if someone could post some stuff in there to maybe add some comments saying what things it'd be great to have wiki information on, because I've got some kind of basic generic tutorials up there that should help beginners find their way through some of the basic API, but that's about it. Anything complex isn't on there, so that needs to be fixed at some point. And apart from that, the progress is going pretty cool. So another important update is that from 0.4 till 0.5, we now aren't going to be breaking any API. So you can change your version from 0.4 to any kind of 0.4 something without any API breaking, which is great. So I'm following the semantic versioning scheme to a certain extent. And that was it. So thanks for staying with me for the rest of the stream, and have a happy Christmas.